Okay, so remember that with a topological ordering, we need to have that every single edge from, say, U to V has to have it so that U must be before V in our ordering. So the way I would do this is I would just go through all of them. So let's look at F first, right? Look at the outgoing edges from F, right? And make sure there's no outgoing edges going to a previous vertex, which there are no previous vertexes, so it's fine. With G, make sure there's no outgoing edge to F. With E, make sure there's no outgoing edges to F and G, so on and so forth. If you find one, then it's not in topological ordering. And if you go through all of them and you don't find one, then it is in topological ordering. One other way that you could do it, I suppose, is you can just draw out all of your nodes. So you'd have F, G, E, C, D, A, B, H nodes. And just actually draw the vertices, right? So you'd have something like this. You'd have something like this. And once you draw them all, if you see any arrows going from the right to the left like this, then it's not in topological ordering. Otherwise, it is. Yeah, that's question 2. It's pretty simple. Question 3 is a nice and simple one. We have to make sure that it's in polynomial time. So basically, if it's in polynomial time, it will be bound by some nm to the power of k, where k is really anything. In this case, you have 2 of them, so this is not polynomial. Pretty simple. These are all polynomial terms, because this would just be, okay, log is still polynomial, it's still bound by this. So this would be yes, this would be yes, and the gimmick is just for question 3, where 2 to the log base 2m is just equal to m. So this is really just n plus m minus 1, and this is polynomial time. This similarly is not polynomial because you have n to the m. So it doesn't really matter what it's to. It's 2 to the m, n to the m. It's all not bound by any of these for any k. So yeah, nice and simple. Question 4, the correct way to do it would be to run Edmonds Karp or Ford-Fulkerson. And just recall that the max flow is equal to the min cut. So once you find the max flow, that's your value, and that's your answer. I'm just going to eyeball it, and that's probably what I would do in the exam, and come back later and run Ford-Fulkerson. But I just eyeball it, make sure S is on one side, T is on the other side, and it makes them into all disjoint. And I can just see it's 5, so yeah, trust me, bro. This next question is actually a bit tricky. Lots of people see that, hey, oh, I see an integer here, so it must be integer linear programming. This isn't necessarily the case, because with integer linear programming, it requires that the integer condition be on one or more decision variables. Now, in our case, sure, the decision variable is this, right? It's the thing that we are choosing to change, basically. Now, if this were to say instead, any real number, then even though these are all integers, it will not be integer linear programming. So just be careful with that. And obviously, you have a polynomial time algorithm for linear programming, but none for integer linear programming. And this is just part of the course slides. Question 6 is easy but tedious, but there is one sort of catch that catches people off guard. Recall that this is a longest proper suffix. So for example, if I have k equals 1, then I'm considering the string with just b. I cannot leave it as 1, because in the same way that for ABC is not a proper suffix. BC and C are. So you can't use the entire string. So it'd be 0 here. Other than that, it's pretty simple. So for example, let's look at 4. For k equals 4, I have BAAB, and obviously these two are the exact same, so I'm going to use 1. A more interesting example would probably be k equals 8. I would have BAAB, BAAB. This suffix is the same as this prefix, so I would have a 4 right here. And really just going through and checking for suffixes equal to prefixes and picking the largest one that isn't the entire string. Yeah. Question 7 is very simple. They want me to partition it into blocks of 3, so I've just basically placed dividers for every 3 elements. And now you just need to sort each one. So 1, 9, 12, 4, 6, 7, 2, 5, 11, 8, 13, 15, and 3, 10, 14. From here, I just take all the medians, so I have 9, 6, 5, 13, 10. I'm going to sort that, so it's going to be 5, 6, 9, 10, 13. And I just picked the middle one, so it's just going to be 9. It's nice and simple.
Okay, you guys can stop spamming the forum now, thanks.